Today we're going to be talking about perimeter, circumference, and area of different shapes such as square, rectangles, triangles, as well as circles. Um, this should be review for you. However, we will be going over 2 additional postulates today that you will need to add to your notebook. So first of all, we're going to talk about perimeter of these different shapes. So perimeter is just adding up all the different side lengths. So in this case, in a square, we have side length S, okay, it says right there. Now, in a square, we know that all the sides are the same length. So if we know that, for instance, this is 2, okay, we know that this is going to be 2, this will be 2, this will be 2, as well as this. All right, so when we're finding the perimeter, we can actually say 4 times S, because in this case, we know that 2 plus 2 plus 2 plus 2 is the same as just multiplying 2 times 4, which in this case would be 8. All right, moving on to the rectangle. In this case, we have a length and a width. All right, we have a length and a width. Now, on a rectangle, we know that the lengths are the same size and the widths are the same size. So, going with the same idea as with the square, instead of just adding them all up, we can actually make a formula out of this. We could say 2 length plus 2W, because there are 2 lengths and 2 widths. Okay? Alright, and last but not least, we have side A, B, and C in our triangle. And we can just add up, in this case, A plus B plus C. Alright? There's no way to do anything fancier with this. Okay? Alright, so that would do it for all the different ways to find perimeter. Now, area is a little bit different. Area is finding the amount of space that's inside the shape. Okay? Inside the shape. So what we're going to need to do is we're going to need to multiply side times a side. Alright, so in this case we could say side squared, because we know that the sides are the same number, so if we just square them on a square, we can just find the area. Alright, on a rectangle, however, you can't just square one because our sides are not all the same length. So in this case, carrying on with the same idea, we're going to do length times width. Length times width. Alright. Alright, so let's say our length is 5 and our width is 3. If we were to find the area, we would do 5 times 3, and our area would be 15. And then we don't have a unit specified, so we could just say units squared. Okay? Alright, now, with the triangle, however, it gets a little bit more difficult. So we have our side length A. However, we also have, what you can notice about here is normally the area formula is, of a triangle is 1/2 base times height. Now, if you look on here, we don't really have a height because this side is not representative of the height, so we need to create one. So we can go doop and doop to make it into a 90-degree angle, and this will be our height. Okay? Now, they will always tell you when you're finding the area what that height is. They will rarely, if ever, ask you to find the height. Okay? Alright, so those are all our formulas for squares, rectangles, and triangles. Alright, we're going to move on to circles now. Circles are a little bit more complicated because while we still have the area, which is a word we're very familiar with, we have something called a circumference. And a circumference is basically the same thing as perimeter. It's the perimeter of a circle. It's what goes all the way around the circle. Whereas area is the inside of the circle. So we have two different formulas for circles when it comes to circumference and area. Alright, we have, and this is kind of a strange looking pie, but you get the picture. Alright, we have, for area, we have pi r squared. Okay? Pi r squared. For circumference, we have two different formulas. We can do it two different ways. We can multiply pi times the diameter, or we can say pi 2 pi r, where we're using the radius, multiplying it by 2, which will get us the diameter, and then multiplying it by pi. Alright, it's whatever is easiest for you, either one works. Okay, so let's do an example real quick. So it says find the circumference and area of each circle round to the nearest tenth. I'm just going to find the circumference of this circle and the area of this circle to make the, so you get the point, okay? Alright, so the first things we're going to do is if we're finding the circumference of this circle, we're going to write down uh, our formula. So we have pi, and in this case, since it's giving me the diameter, I'm going to do pi d. Okay. All right. So if I were to do pi d, it would be pi times the diameter, which is 1. Okay. We're multiplying those. And if we did 3.14 times 1, it would just be 3.14. So let's check it. The circumference is, they rounded it, is 3.1 feet. 3.1 feet. Okay? They stuck with the measurement on the circle. So we could say it is 3, we're going to be more exact, 3.14 feet. And because it's the circumference, it's just feet. Okay? Because we're just finding the perimeter of the circle. Alright, now in the second circle we're going to do the area. So area is pi r squared. Okay, so our radius here is 4 meters, so we're going to do pi times 4 squared. And 4 squared is 16, so we have 16 times pi, which is 3.14, and we will get 50.2 meters squared. Now notice in the area you're always squaring your units, okay? Alright. Now, to go over the postulates we have today, we have two of them. They're very, very self-explanatory, okay? The first postulate states that if two figures are congruent, then their areas are equal. So if we have two of the exact same shape, so for instance, we have a square, and we were to take another one of that square, all right, and we were to say that this this side is the same length as this side, then we could say that the areas are also equal. Okay? All right, the second postulate we have today is postulate 110, and that is the area of a region is the sum of the areas of its non-overlapping parts. So we can look at this shape here to see what they're talking about with this. So So in this case, we can actually split our shape into some different parts that are not overlapping or non-overlapping parts. So in this case, we could take this and this, and we're going to pretend that's a straight line. Okay. And in this case, we now have three separate triangles. Okay. So the tick marks are telling us that this is also 6 because it is congruent to this side. And all of these sides are 2. So we can say this is 2. All right, we can say this is 2. We can say this is 2. All right, so this is the more obvious figure right here, okay? So if we were to find the area of this figure, we would do 6 times 2, which is 12, okay? This one's also very easy. We have 2 times 2, which would be 4. All right, now the middle section is a little difficult. We did create rectangles here. So we have, we've split this in 2 pieces. So if you were to take this and actually extend it out, okay, this whole side would be 6. So we need to find just this little side right here. So in that case, it would be 4, okay? That side would be 4. And the area of that section 4 times 2 would be 8. All right, so now I have the area of 3 separate parts. I have 12. All right, this section right here. I have 8. And I have 4. So if I were to add those up, I can do 12 plus 8 plus 4, which is the sum, okay, of the non-overlapping parts. And that would be 24. 24. And then to tack on our units, we have centimeters. And since we did find the area, it would be squared. Okay? So that concludes our lesson today about area, perimeter, and circumference.